Welcome everyone to the Edelman competition. My name's Ann Robinson. I'm the chair of this year's competition. I ask that you all please silence your cell phones and minimize any other noise as this session is being recorded. The way that the presentation will work, the finalists will have 40 minutes to present their work and then 10 minutes with the judges. Please welcome the second finalist from BHP Billiton.
Las Vegas, the world's #1 destination for card and dice games. Make no mistake though, BHP Billiton is not rolling the dice on its Janssen project. Our creation, which we have affectionately named DICE, is a rigorous operations research model of the Janssen mine that significantly has improved production capacity. Good morning, my name is Giles Hellier. I'm the President of BHP Billiton of Canada. AMAC Foster Wheeler and BHP Billiton are very honoured to be here today to share with you the story of DICE. As Janssen is a project still in development, this presentation will contain forward-looking statements that represent our views at the time and are subject to uncertainty that may cause outcomes to differ. To safeguard information about Janssen's market entry, many project metrics will be stated in relative rather than absolute terms. BHP Billiton is a world leader in the discovery, acquisition, development and marketing of natural resources. Iron ore supports our skyscrapers, coal powers our homes, gas fuels our cars, copper runs through our computers. Our products are the raw materials fueling not just today's growth, but the growth over the next century. We are focused on developing and growing our portfolio to continue to meet the changing needs of our customers. Our strategy is to own and operate long life, low cost, expandable upstream assets that are diversified by commodity, by market and geography. Potash is a plant fertilizer. It meets all of these criteria. It could become the 5th commodity in our portfolio. Let's now listen to the compelling story of potash.
Every day, we are proud of what we do, and we are reminded of what we all have in common, here in Saskatchewan and around the world.
In India.
Here in China.
And here in Brazil.
It's about food and a key nutrient for food.
This is potash.
A resource for the next 100 years and beyond.
We are BHP Billiton, a global diversified resources company. We believe in looking forward. In a changing world, potash and Saskatchewan are a natural part of our future, our long-term growth, our core values.
It's about feeding the future.
With Saskatchewan.
And with BHP Billiton.
The world is growing by more than 75 million people a year, and so is our need for food. By the year 2050, global demand for food is expected to double, but the land we can grow it on is limited.
Feeding the future is one of our century's greatest challenges.
Potash is part of the solution.
Potash is a mineral high in potassium, a key ingredient in fertilizer, and a key nutrient for plants. It improves growth and boosts crop yields. The use of fertilizers is responsible for approximately half of the world's current food production, and we will need more fertilizer and more potash to feed our growing population.
At BHP Billiton, we are perfectly positioned to play a key role in helping to feed the world.
To develop one of the greatest natural resources of this century and beyond.
We have the world's best potash 1 kilometer down.
Saskatchewan has approximately 40% of the world's known potash reserves, running underground for hundreds of kilometers across the province. Enough potash to supply global demand for several hundred years. BHP Billiton has significant land holdings here, perfectly positioned over this incredible major resource.
In a recent survey that looked at almost 100 jurisdictions, Saskatchewan was deemed one of the top jurisdictions in which to do mineral exploration and development. We've got a great commodity, we've got a stable political environment, we've got a workforce that's ready. I can't imagine a better place to be doing business today.
It's a great place to live and work in the community and with the community.
The project means literally thousands of new jobs to the local economy. The use of technology means we're going to build a bigger, better, and safer mine. This gives us the potential to develop a series of mines which will ensure Saskatchewan has a great position as global demand for potash continues to rise. Janssen is the start of a global potash business.
This is the start of Janssen, the first conventional Greenfield potash mine being developed in Saskatchewan in over 4 decades. This is an exciting time for us to be building what we believe to be the safest and the most technologically advanced potash mine in the world. With this tremendous investment, though, comes 3 challenges: working with a commodity that is brand new to BHP Billiton, developing the company's first asset in Canada for many years, and building a brand new and very large mine requiring the investment of billions of dollars. An investment as large as Janssen requires a lot of rigour, a lot of discipline. It requires a lot of innovation in design to create value. This will improve predictability of production and in turn enable Janssen to become a very low-cost producer, which it needs to be. To meet our objectives, operations research has pushed our technical capabilities to an unprecedented level. An advanced tool, which we would be calling DICE, is the Detailed Integrated Capacity Estimate Model. Let's now listen to our Chief Technology Officer, Diane Juergens, speak about the significant role that operations research plays in our company.
At BHP Billiton, our core priorities of safety, culture, and productivity are enduring. A year ago, our CEO, Andrew McKenzie, outlined a strategy to create additional value and improve returns, with productivity as a key component to this plan. We have delivered $1.2 billion of productivity gains in the past 6 months, following the $11 billion of annualized gains secured over the last 4 years. The importance of technology to our company has grown exponentially, and operations research is a key pillar in our strategy and innovation capability. There are many examples where operations research has modeled and analyzed problems to make our assets and capital programs more efficient, and one of the best examples is at Janssen. BHP Billiton and Amick Foster Wheeler are honored to be nominated for the Franz Edelman Award and extend our sincere appreciation to Informs. We are excited to hear your continued feedback and congratulate our fellow nominees.
DICE has had real and significant influential impact on Janssen. It's, amongst other factors, it allowed us to cut $300 million from our current budget. DICE enabled the board to approve the transition of the project from pre-feasibility to a feasibility study phase. DICE was very instrumental in creating the feasibility study proposal, which the board also needed to approve. More specifics will come later, but now let me introduce to you David Bleicher, Vice President of Amick Foster Wheeler Mining, and explain how DICE fits into the project world.
Amick Foster Wheeler designs and delivers and maintains strategic and complex assets for its customers across the global resource and related sectors. We've been developing models for the mining, mineral processing, and transportation industries and supply chain industries since 1997. BHP Billiton and AMEC Foster Wheeler have a long history of collaborating and working together on over 200 assignments. A key feature of our relationship has been maintaining a continuous improvement ethos and a constant focus on innovation. These also underpin our relationship on Janssen. BHP Billiton shareholders require a high return on their investment in Janssen's construction to justify the inherent risks in mining investments. It's a very large capital project, and like any other of its size, Janssen is designed and built in successive phases over a duration as long as 10 years, with the two key milestones of scope lock and sanction. Each phase seeks to reduce capex, improve net present value, minimize risks, and provide greater certainty in design, construction, operation, and greater certainty in profitability. For BHP Billiton, the need to build an optimized operation at Janssen has been recognized from the earliest phases of the project. In the early phases, the opportunity for design change is higher, and the cost of such changes is lower. DICE is the right tool deployed at the right time. We have an incredible opportunity to effect change when it will give the least rework, the greatest buy-in, the lowest cost, and overall, the most value for Janssen. That's why DICE has such merits here and now. We only have one chance to build Janssen right. Janssen is a mine-to-customer chain, beginning with the production areas of mining, hoisting, and processing, and the distribution areas of rail, port, and customers. It links our mine in Saskatchewan to the distant west coast of North America. During the conceptual study, we developed models for selected areas. The models were not integrated and lacked detail to validate the process flow diagrams. The model inputs were also not adequately understood or benchmarked. We were cognizant of these gaps and knew we would need to develop a more integrated approach for pre-feasibility. DICE would become the integrated, overarching model of production capacity. Let's now listen to Tina Markovic, head of production, reflect on the evolution she's seen from concept to pre-feasibility.
During the conceptual study, the operational readiness team that I was leading began using models to inform the design, capital intensity, and operating productivity for Janssen. I return now to Janssen after an absence of working in Australia and Chile for BHP Billiton. The DICE team has made a remarkable step change in integrating the several small complex models we had into one single large complete model, modeling right from the underground mine face right through to the port and to the customers, the entire production value chain of Janssen. Using DICE to make holistic, unbiased, and timely decisions was also a key difference from conceptual to pre-feasibility phases. I am excited that DICE will evolve from an equipment-based model to one now encompassing labor, enabling further design opportunities to increase operational productivity. As head of production, I am equally excited to use DICE during ramp-up in the production phases, allowing us to identify continuous improvement opportunities for operational productivity. DICE is truly a transferable model, allowing us to go from the development, construction, and into the operational phase.
Here's Keith Kwan, manager of AMEC Foster Wheeler's Operations Analysis Group, to tell you more about our methodology. Keith.
Thanks, David. Integration played a fundamental role in our success. The integration of the production and logistics segments of the chain enabled us to find opportunities for improvement in places we were not considering, that is, at the interfaces. DICE had many stakeholders who understood that optimization should be done globally, not locally, and that certain assets, even though they were expensive, should be secondary to the bottlenecks. Our key performance indicators were defined in isolation. Were not defined in isolation, but rather aligned to one metric, and that was to maximize the value of Janssen. An integrated scope, an integrated team, and not least of all, an integrated technique, all working in unison. At the heart of DICE is a discrete event simulation model using multiple OR techniques. A detailed capacity analysis provides us with the integrated capacity of the entire value chain. Constraints analysis pinpoints the bottleneck. Reliability, availability, and maintainability analysis identifies the most significant causes of lost production. Monte Carlo simulation generates the randomness and variability inherent in real-world systems. And finally, forecasting algorithms and inventory theory are used extensively throughout the supply chain portion of the model to balance mine production and potash sales. In isolation, any one of these techniques is not necessarily novel. However, working in an integrated way within the one engine that we call DICE, we truly have a novel solution. The whole is indeed greater than the sum of the parts. And without a doubt, DICE is the most detailed and complex simulation model Amec Foster Wheeler has ever developed. This short video will show you the scale and complexity of the project.
1 kilometer down, a technique similar to long room and pillar mining will be used with added innovation. Equipment customized to suit local conditions will greatly improve efficiency. Larger, 2-rotor borers will mean each machine only needs to do 2 horizontal passes in each room, rather than the traditional 4, to mine the complete wall. This is expected to give us the highest productivity levels in the industry. Over the course of the next 70 years, we'll mine an area of some 600 square kilometers. That's equivalent to the area of a city like Toronto, except that it's 1 kilometer underground. The permanent headframes over the 2 shafts will be 115 and 97 meters tall, making them amongst the tallest structures in Saskatchewan.
In the nearby processing plant, potash will be separated from the ore, screened, refined, and stored before transport. When complete, these plants will be amongst the most advanced in the world. A new generation of rail cars, which can be continuously loaded and unloaded without manual intervention, will speed up load times and work as part of a seamless, integrated logistics chain, taking potash by rail from the mine to the port.
As you've seen, there are many static and moving parts in the Janssen chain across its 5 distinct areas. Choosing the process area to be the bottleneck was the first and most important decision we made. DICE was truly instrumental to this end. And that's why we've included in the process submodel space up to 2,000 individual pieces of equipment. And these can be configured to any design. In addition, DICE allows for up to 5,000 lines of input data to define maintenance and failures. The next area of importance was mining. Our plan to use new technology to mine potash, and therefore our need to understand the risks of this technology, fully justified the high level of detail in this area. The other areas were generally simpler, but no less important. All in all, the model has over 140,000 configurable inputs, each with different levels of influence, variability, and uncertainty. We can best summarize DICE in this way: high granularity of time, high complexity in the processes, and high details in the equipment. I'd like to introduce Brian Monk, Amec Foster Wheeler's lead for the DICE model, to share some salient results from across the chain. Thank you.
Thanks, Keith. With DICE, our objective was to find the optimum combination of capital costs, operating costs, and production capacity to maximize the project's net present value. We focused on the upstream value portion of the value chain. In the mining area, we determined the right number of borers and spares. Borers are purpose-built assets worth millions of dollars, and determining the correct number is a significant capex driver. We also uncovered significant operating gains, something only made possible by incorporating an incredible level of detail. DICE models people traveling down the shaft, collecting their tools, checking their vehicles, traveling to the borers, even taking coffee breaks. Literally every possible event that can impact performance is accounted for. And this allowed us to discover value in something called hot seating and automation, a combination of staff scheduling and self-operating technology that increased operational availability by up to 25%. So in the mine area, we achieved MPV gains through the incorporation of detail. But in the hoist area, we achieved gains through the overarching nature of the model. Very importantly, DICE verified that Janssen's production in its first stage of development would require only one shaft, and that the second shaft would only be needed to support future stages. And this has lowered the cost of the initial capital budget by $300 million. We also captured operational gains in the interfaces between areas. DICE showed that by aligning hoist inspections with a regular mill outage, we could add $60 million to the NPV, and this gain at no additional cost. As Keith mentioned, the bottleneck of the chain is the process area. Constraint theory tells us that the largest capacity gains would be realized there, and they were. DICE uses a short 2-minute time step, and this provided granularity that was of particular value in the mill, where we added bypasses, refined equipment arrangements, and optimized buffer capacities. From a capital perspective, we found it value destructive to shrink the stockpile ahead of the mill. We kept the size unchanged to always have a large inventory of ore, and we added a stockpile bypass to permit greater ore flow optionality between the hoist and the mill. We also used the model to optimize the frequency of outages, a task normally reserved for a reliability model, but one that DICE's complexity was able to absorb. All told, we banked $87 million of gains in the process area. Over the course of 2 years, we performed well over 1,000 simulation scenarios. And while a majority focused on reducing downtime, which we identified as the key value driver, we chased gains in every part of the chain. The majority of these gains, around 58%, came from the process mill, where the bottleneck is located. Surprisingly, 42% came from the hoist and mine. Overall, from the start of pre-feasibility to the end, the project realized a production capacity gain of 15 to 20%. That is 15 to 20% more revenue every year for the entire life of mine. And DICE can be credited with 2/3 of this gain. Dr. Sylvie Bouffard, BHP Billiton Manager of Optimization, will now summarize the multiple positive and significant impacts of these design and operational changes.
Thank you, Brian. As Giles mentioned, the impact of DICE was threefold: technical, financial, and organizational. From a technical perspective, DICE was instrumental in defining the work to be done during the feasibility study. This seems like a rather soft, intangible impact, but knowing what needs to be done is absolutely necessary to figuring out how to execute this work, to create a schedule for it, and also to evaluate how much it will cost. Scope, execution, schedule, and cost is what defines our feasibility proposal. And without it, the board would never ever approve our launch into feasibility. We're about to hear from 3 of our stakeholders speaking of the usefulness of DICE in shaping their study proposal. First, here is Cheryl from the mining team.
DICE showed us that it was more important for the setup and maintenance activities for the borer mining systems to be done efficiently and consistently, as opposed to the rate at which the borers mine potash. In the feasibility study, we plan to do an extensive, full-scale demonstration of the borer mining system in an operating underground mine. With this valuable insight from DICE, we have ensured our test program includes repeated measurements of the critical setup and maintenance activities.
In this presentation, we've given all the attention and spotlight to DICE, and we've been so far silent about our latest creation, the SLICE model, the Simplified Linear Integrated Capacity Estimate Model. SLICE and DICE are very complementary, but the added benefit from SLICE is its better ability to increase the predictability of Janssen's production. Here is Tony Eltringham, former vice president at BHP Billiton, and now a consultant on our project, speaking of the value of DICE in the hoist area.
The team has transferred the structure of DICE into another model, which they call SLICE, the Simplified Linear Integrated Capacity Estimate Model. SLICE is more powerful than DICE for Monte Carlo analysis, and it has shown that Janssen would see its bottleneck hopping from the mill to the hoist and then back again approximately 50% of the time. The hopping bottleneck was first clearly identified by the father of constraint theory, Dr. Elie Goldratt. This is the result of the stockpile ahead of the mill not being able to protect the mill from variations upstream. This is a key optimization opportunity during the feasibility study, and the ability of SLICE to identify these instabilities that cause a less predictable throughput is a very powerful enabler.
Last but certainly not least is the process area, where details and complexity abound, and where the potential for more savings is to come. Here is Brian Jackson, study manager of our new EPCM provider, on the transferability of DICE to the engineering team.
The Hatch-Bantrell joint venture is providing EPCM services for the Janssen feasibility study, and the DICE model is a fantastic platform for our team. The level of detail that DICE offers in the mining, hoist, and process areas is remarkable and is well suited to our optimization efforts. As the bottleneck, the process mill is the most promising area where we hope to unlock the gains in capacity that we are seeking during the feasibility study.
Janssen will have a long life, operating for many decades, and during this time, we plan to build Janssen in multiple stages. When at full capacity, the 2 shafts that are presently under construction will be needed, but until then, 1 shaft will be sufficient. Therefore, we have decided to stop the construction of the permanent head frame on the production shaft, and with that decision, we were able to cut $300 million from our initial capital budget, which is equivalent to a one-time 10% cost reduction. Ryan mentioned how our optimization work led to a significant increase of the production capacity by about 15 to 20% in stage 1. And from a financial perspective, this added more than $500 million to the project NPV for stage 1 alone. And for the overall project, including stage 1 and all future stages to come, an NPV gain of 12 to 16%. Higher production capacity and earlier revenues will make Janssen more appealing to an investor. The project economics are described as a range of possible NPV outcomes that are subject to the uncertainty of internal and external value drivers. The yellow distribution corresponds to the start of the pre-feasibility study. The blue one marks the end. The 2 distributions do span the same range, but what's important is the significant shift to the right to the more NPV positive value by the end of the study. We can quantify this shift using one metric, the probability that the project will have a positive NPV. On an absolute basis, DICE increased that probability by 30 percentage points. This NPV has not been realized yet, but the shift in NPV from the start to the end is very tangible, very real, and very significant. In consideration of this, amongst other factors, the board of BHP Billiton has approved the transition of our project from pre-feasibility to feasibility study. This is the first of two very important milestones that David spoke about, and one that preserved the $3 billion of value that we've already invested at Janssen. Let us listen now to our Chief Commercial Officer, Dean Della Valle, describe the significance of this milestone.
While Janssen has not yet come of age with sanction, the board's decision to progress the project into feasibility study is an internal milestone to celebrate. During the feasibility study, the project team will continue to improve value to reaffirm that Janssen is a compelling project. The DICE model will continue to be the unifying, advanced analytic tool that it is, protecting the value captured in the pre-feasibility study and seeking more in feasibility. Congratulations to the DICE team and the Janssen project team, and also to the other Edelman finalists on realising gains in capital and operating productivity.
Thanks, thanks, Sylvie. Many see resources and certainly mining as a relatively low-tech industry. And some see it as an industry in decline whose golden years are behind it. But our industry reaches well beyond the narrow confines of companies digging stuff up and just putting it on a vessel. Technology and innovation has been such an important part of our ongoing success story. At BHP Billiton, the past few years have seen us very strongly focused on becoming more productive, and operations research is a major contributor to that effort. We are excited by the transformational success of our project. We are one of the largest mining companies in the world, using operations research as a tool, and DICE to help us make decisions on this multi-billion-dollar project. Better decision-making focused on the common goal of maximising value globally, that is the power of DICE. The richness of DICE has enabled us to use modern real-life mining activities in their purest form, and our greater understanding of the criticality, the variability, the uncertainty of the thousands of inputs that DICE has made has really created Janssen to be a more timely, more productive and more predictable project. We have conferred to DICE the special status of the gatekeeper in that every decision that impacts production was put to an unbiased scrutiny before being presented to the study committee, the main governance body for the project. We celebrated the board's decision to progress into feasibility and will continue embracing DICE and SLICE on our journey to sanction. Developing a project like Janssen is a massive capital investment, and we have a huge responsibility to our shareholders to spend their money and their capital wisely. With what's given to us, we only have one chance to build Janssen, and that's to build it right the first time. So the decision in 2015 to develop DICE resulted in a reduction of $300 million in savings for stage one. It increased the likelihood of a positive project net present value by 30% and provided us with a robust case to take to our board in August of 2016. The board toggated the project from the feasibility or pre-feasibility to feasibility study stage, thereby preserving the value of the almost $3 billion investment that we've invested so far in Janssen and set the stage for the potential investment of billions more. Thanks to DICE, we are one step closer to sanctioning Janssen and making potash the fifth pillar in the BHP Billiton portfolio. So in the decade 2020, when Janssen will be in operation, our daughters, our sons, were likely to be operators, engineers and managers at Janssen, and they will never know the Janssen that would have been without DICE, because our efforts today, using operations research, have created a more capital efficient asset, and one that, thanks to automation and scheduling, is also going to be more operationally efficient. Thanks to Janssen, more competitive in our industry we will be, ensuring that we will supply potash for a century to come, helping farmers achieve crop yields to feed a growing world population. We are very humbled to be honoured to be a finalist in the Franz Edelman Award, and we greatly appreciate your consideration of our work. Thank you from myself and from the team.